Yes, dear student, now see here. The topic is rotational kinetic energy. You have learned if a body of mass m is moving with velocity v, then its kinetic energy is given by half mv square. Using that concept, kinetic energy is equal to half mv square. This is called linear kinetic energy. V is the mass, velocity, m is the mass. So we will obtain expression for rotational kinetic energy using the same. Okay. So in figure I have shown a rigid body. This is a rigid body here. Rigid body, I told you, a body, if we apply force at any point, either there occur no displacement, or if there is a displacement, then all particles of body get equally displaced. Then body is called rigid body. So let in figure a rigid body. A rigid body made up of many point masses m1, m2, m3, so on up to mn, is rotating with constant angular velocity omega about an axis passing through point O and normal to the plane of body. This thing is actually appears difficult in writing, but simple thing. If I want to rotate this body, then I suppose I make here a hole and rotate like this. So the axis rotation is normal to plane of this body. Is that clear? Since body is rigid, so angular velocity of all particles is the same. Let the distances of masses m1, m2, m3, so on up to mn be r1, r2, r3, so on, up to rn respectively. Since body is rigid, so all particles have same angular velocity. Since body is rigid, so every particle has same angular velocity omega. We know a body is moving with the angular, it has linear velocity. We know linear velocity V and angular velocity of angular velocity omega of a body are related by equation V equal to R omega. Every point mass m1, m2, m3, m4 have same angular velocity, but because of their distance from axis rotation, their linear velocities are different. According to this equation, due to different distances of particles from axis of rotation, the linear velocities are different. And these velocities are given by V1 equal to R1 omega, comma V2 equal to R2 omega, V3 equal to R3 omega, and so on, Rn omega. These are linear velocities, so the kinetic energy, kinetic energy of different particles of body are given by kinetic energies are given by K1 equal to half m1 v1 square, but v1 equal to r1 omega, so equal to half m r1 square omega square. K2 similarly equal to half m2 r2 square omega square. K3 equal to half m3 r3 square omega square, so on up to kn half m n r n square omega square. And sum of the kinetic energy of all particles here will be equal to rotational energy of the body. Sum of all these kinetic energy, sum of all these kinetic energies will be equal to rotational kinetic energy. So about the kinetic energies kinetic rotational energy of the body. that is rotational. Ke is equal to half m1 square m1 r1 square plus m2 r2 square plus m3 r3 square so on up to mn rn square into ओमेगा स्क्वायर भी भाई बात सॉरी ओमेगा सब में कॉमन हो जाएगा and this Ke equal to rotational energy half we can write it as summation mi square I equal to 1 to n into omega square, and I hope now you will be recalling what is this summation mi square. What is the summation mi square? I hope you may answer this, but you are not with me here, so I have to tell this. But summation mi square I equal to 1 to n. I equal to 1 to n equal to I. I means moment of inertia. Moment of inertia of body about axis of rotation. I hope you have got it. आपको याद आ गया होगा ये क्या है summation mi square, and please learn the moment of inertia of different bodies about different axes, and I gave the moment of inertia of different bodies about different axes in table. So rotation का एनर्जी क्या होगा भाई? Hence rotation का एनर्जी rotational kinetic energy equal to half I omega square. See here in translated energy which was half m omega half mv square. Here role of mass played by I, role of velocity played by omega. So there is a analogy between rectangular motion and rotating motion. ठीक है भाई? तो it was rotation का energy. Now it depends on I and omega, and I depend on distance of particle from axial rotation. Okay, I hope you have got it and you will enjoy it. The same way, there is a relation between moment of inertia and angular momentum. I have explained you the meaning of linear angular momentum. I have given detail, and finally I told you that angular momentum is vector product of position vector and linear momentum. Linear momentum P is equal to mv. The same way, what is the relation of this angular momentum with omega? In the previous videos I have proved L equal to R cross P. P equal to mv, and so many things I proved there. I told angular momentum is vector quantity whose direction is right angle to R and P. So here we want to relate the inner magnitude. The same way we assume here that this body made up of M1, M2, M3 so on particle. M1, M2, M3, M4, M5 and so on. Their distances R1, R2, R3 so on. Moving with constant angular velocity omega. Again. So I will note, you have got it, what is this rigid body rotating about an axis passing through this point O, which is normal to the plane. You know, when you rotate something like wheel, the cycle will rotate about axis, so that axis is rotation. So here angular velocity omega. So V1 is equal to R1 omega. I am writing directly. V2 is equal to R2 omega, V3 equal to R3 omega, and so on. Linear momentum P1, M1 V1, यानी कि M1 V1 R1 ओमेगा, ओमेगा है, ओमेगा की कोमा है यहाँ पर। ऐसे P2 होगा M2 R2 ओमेगा, P2 P3 M3 R3. What are P1 P2? Linear momentum of these particles, because every body in rotating motion has linear velocity. If it has linear velocity, it has angular velocity also. I told you that moment of linear momentum, यानी कि the angular momentum, the magnitude we know. I should write here. We know that magnitude of angular momentum of a particle equal to product of distance of particle from axis of rotation and linear momentum. We have represented in our last video momentum by L. So L1, यानी कि linear momentum of mass M1 will be, इसका distance कितना है R1 into P1. Sorry, R1 into P1. I am taking only magnitude. Or P1 equal to M1 R1 omega. So L1 is equal to R1 into M1 R1 omega. Then it is equal to M1 R1 square omega. Similarly L2 M2 R2 square omega. L3 equal to M3 R3 square omega, and so on. The sum of all these momentum will be the momentum of whole body. So angular momentum of this rigid body about an axis of rotation passing through O and normal plane of rigid body. L is equal to L1 plus L2 plus L3, so on up to plus Ln, यानी कि L is equal to M1 R1 square plus M2 R2 square. We will add all these plus M3 R3 square up to plus Mn Rn square into omega. This is here summation Mi Ri square I equal to 1 to n or into omega, and just now I told this is moment of inertia I. But summation Mi Ri square, but summation Mi Ri square I equal to 1 to n equal to I equal to moment of inertia. Moment of inertia of rigid body about O. So L is equal to I omega. जैसे हमारा P था mv, it is I omega. I will take लेंदी होगा थोड़ा सा. So next video will relate torque and angular momentum.